Assalamualaikum and selamat sejahtera. This time, we will analyze the waveforms based on the general parameters of the rectifiers. Now, let's analyze the output voltage waveform of a single-phase uncontrolled half-wave rectifier. First, we start with the calculation of the average output voltage using this general equation. According to the equation, we need to determine the full period of a complete cycle of the output voltage waveform. Based on the wave shape of the output voltage, we can identify that the full period, which is T, is equal to 2 pi. Hence, we can rewrite the general equation by replacing the T with 2 pi. However, since the area under the graph can be calculated between 0 until pi, therefore, this T should equal to pi only. Based on a complete derivation of the equation, therefore, the average output voltage is equal to Vm per pi. Next, we can sketch the waveform of the average output voltage as follows. To find the RMS output voltage, we can use this general equation. Based on the final equation, we can see that the RMS output voltage of this rectifier is equal to half of the peak amplitude of the output voltage waveform. Thus, we can sketch the waveform as follows. Next, we can use the average and RMS output voltage values to calculate the ripple factor of the waveform. By assuming that the peak amplitude is equal to 1, therefore, the percentage of ripple factor is equal to 121%. Meanwhile, the efficiency of the rectifier is only 41%. For a single-phase uncontrolled full-wave rectifier, we can calculate its average and RMS output voltages using the same general equations applied in the half-wave rectifier. However, based on the wave shape of the output voltage waveform, we can see that the full period of a complete cycle of the waveform is only pi. Moreover, according to the wave shape, we can also set the range of the integral in both equations as 0 and pi. By completing the derivation, we can see that the average output voltage of the full wave rectifier is equal to Vm per pi. Meanwhile, the RMS output voltage is equal to Vm divided by SERT2. Next, based on these equations, we can sketch their waveforms as follows. Finally, the ripple factor and the efficiency of the full wave rectifier are 48% and 81% respectively. I want to highlight the differences between half-wave and full-wave rectifiers. Based on this table, we can differentiate them in terms of circuit topology, number of diodes used in the circuits, their principal operation during the positive and negative half cycle of the AC sources, ripple factor, and efficiency. Based on this parameter, we can see that the full wave rectifier has lower ripple factor with high efficiency. Because of this, we can claim that the performance of full wave rectifier is better than the half wave rectifier.